Hi, this is another Antminer repair video. Tonight we're going to continue a series of found zero Asics on hashboard. And basically this is what my desktop looks like without the board underneath, because I'm working on quite a few boards at once. But tonight we're going to finish up a series on finding, we had this hashboard, which is a T17 hashboard, and we found zero Asics on it. And on the last video, I was preparing to really swap out chip number 30, which I think is right here. It had some funny resistance with these two capacitors right here, maybe a little bit more than usual. It still does. But I was rather uncomfortable doing it because it didn't show any other symptoms testing the voltages. It was basically perfect. So I did some more testing and I want to discuss my findings, and what I found is quite interesting. So if you like this content or it does you good, you can hit subscribe on my YouTube channel. We're not going to get 10 million subscribers because not everyone's doing this activity, obviously. You guys who are watching it know what you're doing, and you know kind of it's not a widespread thing. You can also, there's a little bell there if you just want to be notified when I create a new video. If you click on that bell, it'll send you a notification, hey, there's a new video that I did. And they're really, at least right now, mostly going to be centered on this BM13 94 97 chip, which most all Antminers use. And I think you can take what I do here and propagate it out to other boards. So also in the description of the video, I have a PayPal address and a receive Bitcoin address. And if you think I saved you money and you want to donate to the cause, I'm not really doing this for profit, but I shelled out enough money to do this. Appreciate some help if you finally get started and do this yourself. The goal of these videos are to empower yourself to start to repair your own cards, so you're not helpless and sending cards to China to get repaired or at the mercy of people, because there's a whole lot you can do yourself without being an expert. I'm about, what, month and a half in, and I've learned all this stuff just by hardcore concentration. So, all right, so today's video, I'm gonna pick up where we left off and just give you a review. The first video is actually labeling on swapping a chip on an Antminer board. And I had to change it because I kind of backpedaled after I really looked at stuff. I took off 4 chips here to kind of demonstrate, hey, I'm going to start preparing the board. We're doing this chip, but I need room to work. So I kind of made a space to work on. And so started doing that. I was probably even going to pull the chip off. And I just kind of felt uncomfortable. I just didn't have clear signal that this was a problem. And always in the back of my head, I keep thinking that there's a problem that could happen, like on this chip, that just shuts the rest of the board off and gives zero ASIC. So we've been kind of taught, the people I've watched anyway, hey, it's either the first chip or the second chip if you got zero ASIC, or absolutely a power for the chips. I started with that and kind of said, hey, I don't even know if I'm going to publish this video. I'm going to take the board apart and look at it some more. So on part 2 of this series, I think that was part 1. I think part 2 or part 3, I can't remember now, but you guys can look up on YouTube. I actually offline took the time and unsoldered all these heat sinks. This is the board without the top heat sinks. I do have the bottom heat sinks on, but this is the board without the top heat sinks. And I looked at every single pins to look for solder balls. And so I have a very short video. I think it's part 3. I actually found a real significant solder ball, and I couldn't tell you where I found it now. It was probably somewhere around here. And I show that I discovered. I started up the video and said, hey, here's what I found. I'm kind of curious if this stopped it from being zero ASIC. So that was up till last time I've caught you up. So I took it out to the, it's time for my clock to go off. I have fun with little clocks here and there too. So I took it out to my testing area, and unfortunately it's not conducive for video. It's kind of like walking in the crypto guys' trailer where it's got 15 billion machines running in the SDL. I'm not going to do that. It's my garage. I got fans blowing. It's kind of crazy. Probably a lot of what you guys are doing. So just take it. I spent a good hour at least, and you can kind of see them up here. I'm right here and right here, and actually they're in between. These are the test points, and I methodically, for the most part, walked through the board and looked at the signals. Now this card, there's 5 test ports. If you can kind of see them, I'm sorry my camera doesn't do it, but there's 5 holes that you can put a test plug in, and those 5 holes are right here and right here, and they go at each line, and then they wrap around the bottom. So you could actually see how this moves from here and kind of sweeps along in this order and counts up to 30. So out of those 5, 4 of these signals go forward from here. They originate here and end here. And so you would check to make sure it left each chip and each chip came in. So I ground on the top of the chip and I poke my my negative probe. I have these dudes right here. I just stab myself, but I have the negative probe with a needle on it, and I have the positive probe. And someone at Zeus Mining said in a diagram or a document, say, hey, do it backwards. So I put the positive on the chip, and then I use the pin to poke in a hole. Let me see, I'll move that kind of like that. And I read the voltage when I press the test button. When I press the test button on their tester, for about 3 seconds, it supplies voltage to the chips when it's looking for them. And I can measure the voltage coming in the chip and out the chip. So that's essentially for every chip, I had to make 10 measurements. It takes about a 30, 40 seconds, maybe 50 seconds to run each test. So I'm sitting there pressing the button over and over for each one of these. Then I switch over here, press the button over and over for each one of these, and just kind of move throughout the board. Because I had all the heat sinks off, and it's really easy to do when the heat sinks are off. The one thing you don't want to do is have it find 30 ASICs because you fixed it with a board without heat sinks and then start to hash. You're certainly to fry your board, and I've fried one, and part of this video series will be the rebuilding of that board, and I'll show you the damage it did, and I've got to replace a lot of chips. But I'm not ready to do that yet. I'm still trying to get the low-hanging fruit. This one turns out it's not low-hanging fruit. We bought 3 T17 used Antminers from China, and basically they were no good. I think out of the 3 I might have 1 or 2 cards out of those 3 miners that are hashing today. So I've got this backlog of cards. This is my challenge, and kind of why I wanted to do the video is I've got all these cards that need repaired that someone probably in China where they came from said this card's too far gone, we can't repair it. And some of them worked and some of them didn't. So I'm going through them and trying to figure out what's wrong. So this one had 0 ASIC, and I was focused on here and maybe solder balls. So here's what I found. This board was discarded for a reason. It had too many problems for somebody to spend the time to fix because it takes a long time to fix these. And frankly, putting in chips is a sketchy activity. You miss and you hit and you miss and you hit. Sometimes I get on a roll and could do 4 in a row, and then sometimes I do 5 and never make it. So I start testing along and I test all the voltages. And then let me see, I get to this guy right here. So I'm starting at chip 1 and I get to this guy. And I check the, so the way I go forward is I check to make sure the ones going forward should go there. And then I check the one that originates from here is coming into the chip and exiting, going back. And so when you have a 0 ASIC, you could be talking about this chip or this chip, or as I think I've found, a greater problem with the board. So the first thing I found is the power. I saw some voltage going in here because the RO signal, which is the middle pin, the return signal, comes through here and goes in here. And I measured that. And sure enough, he had some voltage. And then I measured him going out, and it was like 0.022. It should be either 0.8 or 1.7. So it should be a higher volt there. It was nothing. Then I measured here, didn't generate any more. Then I measured here, it didn't generate any more. Then after here, it picked it back up with voltage because there's a power supply that hooks into the middle line right here from the other side of the board and then starts supplying voltage. So I said, wow. But then I thought, well, RO missing, that's just the return. Why didn't it just give me that I found 1, 2, 3, 4, 6, 7, 8, 9, maybe even 9 chips or 12 chips, because it probably fed it all the way up to here and it didn't hit the return. So why wasn't it a 12 chip ASIC find instead of a 0? And I said, well, it's the whole bank. The whole bank is not getting power. I'm assuming because this chip is bad. I have to probably research it a little more. Maybe look at the voltage regulator on the other side and measure some resistance there and just check it out, make sure it's not hot. And those, by the way, if I hold my finger, those are going to be underneath here. So I have to remove these, and there's voltage regulators. And here's some up here. There's 2 of them here, and there's 1 down in here. But the resistance on the voltage regulators is pretty much tied to how the chip handles the resistance. So anyway, I marked this guy because when I do get the other problem for 0 fixed, this is going to show up. This guy's not feeding the return signal back on this line. So we've got an issue here. I just don't know, and I don't think it was enough for a 0 ASIC. Fine. So I kept going. And so I'm cruising along, and I came here, and the signal comes back around here, and I'm measuring the clock signal, which is, it's either this one or this one, either it's one of the sides of the far sides of the test ports. And I've got clock signal coming into this guy with voltage, but hardly any clock signal coming out to the next chip. So this would be your typical clock counter error that maybe the firmware, if you had more than one board in the Antminer, the firmware, the Antminer software might compensate and say, let's borrow the clock off another board of this chip and just maybe think it's the same, or let's extrapolate and maybe use a clock, because I noticed it'll reset on some of them and then that error will go away on the newest firmware. So definitely have a clock signal problem here, and it's not a solder ball. I've looked through the solder balls. Still have to focus on this. I need to check the resistance. I already did that here, I can't remember. So problem number 2 is probably this chip. And the way I tell it's this chip is I can test here on this chip and see it's providing that voltage. Then I'll check here on here and see if the chip is receiving the voltage. And when I don't see it receive the voltage, I'm pretty sure it's the input of this chip isn't getting it. And thus then the output of the chip isn't going to send it. And I think clock probably picks up somewhere back here because it's probably refreshed on this bank. So got a problem with this chip. That again wouldn't stop you from finding the chips on the board. This would give you that clock counter error after it starts applying the final voltage and ramping up to hash. So it's like, okay, well, maybe it could if it was real bad, but I haven't seen a clock problem stop it. You just get that error and maybe the Antminer won't run the card. So I continue on, and actually I missed some stuff and I ended up at this chip over here. And the next inside and the other inside, it's the CI and the, let me flip over, I'm gonna cheat here. It was the reset and the CI. The CI is, I think, a data line, but then there's a reset line that resets the chips. All of a sudden, I went from here to here and there was voltage. Actually, it was over here, but then I backed it out and found out. This used to be marked. For this video, I took it. I started here. Then I worked my way back until I started seeing voltage here, and this is the first chip it happens. I send like 1.7 volts through here. This guy gets 1.3. Then I look what he's sending out. Nothing. Then nothing. Then nothing. Then nothing. So whatever this happened rippled all the way to the end of the board. Nothing. Kind of concerns me because I thought I tested that voltage coming in. I think I did, but for some reason I could not pick up anything on my tests after. And you know why I think I found voltage is in an earlier video I said I like to test on the back of this card, because on the back of this card in between the chips are those test ports, and then you see these ones right here. So either in between the chip here or over here I test. But then I started thinking, if you look at this guy, this is the backing of the chip and represents the ground of the chip. If I test the actual chip, it's actually got to run up through the leg and onto the chip and make sure the chip's grounded. So it goes through the chip circuitry and then ends up on the ground. So I don't think it's a good idea to test from behind anymore. I think you actually have to test the chips. So I've determined, and I already checked the resistances, they're all good. I've determined I've got a problem with this chip and it's cutting off the rest of the board. And I think this problem would cause a zero ASIC because it's never getting there, it's never getting back. On the return signal, never gets back. It's probably deferring to that return signal because it never gets back, I guess. I don't know, but so on this board I found 3 problems. These aren't going to stop it from being 0, but I think this is because when you have a multiple chip problem like this, it's real difficult because so I replaced this, still getting 0 ASIC. How do I know that I replaced this chip right and it's good? I can't run it, I can't test it. So when you have a multiple chip outage like this, you need to test the first thing that you can that will give you results so you can know if that chip transplant was good. So I think if I replace this, I should be getting, it'll probably go not a 30 chip, but it'll probably hit the return line. It'll probably 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. So I should find 18, 19, or 20 chips because this relearn line is back. If I don't find 18, 19, or 20, I might look to see if it lands on this chip when I test it. But this guy, I feel, is probably the most likely candidate that's stopping the whole board for registering any. It just gets to here and there's so much problems. There's nothing coming out of this chip on those 2 ports that it just said, hey, this board's no good, I'm not gonna run. That's not to say there couldn't be other problems. So that's the solution of the 0 ASIC. So what I'm gonna do is I'm gonna start a new video series, the one I intended to do, which is chip replacement. And I don't know that I'll do it 3 times in a row, but I'll go through what I do to transplant these chips. I might do one with a used chip because I got this burned board that I use chips off of. And I might do one with a used chip. I think I'll do them in this order. I think I'll save, I don't know if I'll save clock for last. I'll have to figure out what order. I know this is the first one I'm gonna do though. So that's the video for tonight. Hope it's beneficial for you. And then I'm going to do the next series. It'll probably be 3 or 4 steps to get this new chip in here. The first thing is removing this. The second thing is preparing this service. The third thing is preparing the chip service. And the fourth thing is putting it back on and soldering it with a ton of flux and kind of preparing the area so you don't blow it out. So that's what I'm going to do in the next video series. So stay tuned. If you like this, subscribe, or else if you're watching this way after I did it, go search for, this has part 1 through 4. I'll do replacing a chip part 1 through 4. I don't know if I'll repeat it over and over as I do it with the other boards. Maybe I will. Probably run into different things. I don't know if people get sick of seeing it. But here you go. That's it for tonight. Thank you for watching. And honestly, leave comments. I'll answer them. I want a discussion about this. If you guys have discovered some of the things, I'd like to share the information and have it recorded. What I don't really want to do is look at someone's log and try to guess what's wrong with their card. Let the Antminer engineer do that. He seems to like to do that. So come with something to the table saying, hey, I took this apart, send a photo or something. I don't know. Willing to give an opinion. But if you're doing this and see me doing something different than you do, or something that you like what I did, let me know. Put something in the comments. We'll go from there. So far, the comments I've gotten on this channel are 2 porn sites, and I removed them. So we don't really want that. I don't want to go there. So come on, let's talk about it and maybe help some other people. Thank you. Good night.